Okay, so this presentation is the Presumptive Approach Calculator. I'm Amy Simpson. I'm with the Codes, Rules, and Manuals team. So the PAC, the Presumptive Approach Calculator, the PAC, is a city-provided calculator to size stormwater facilities. It's on the link that's shown here, pac.portland.gov. And it requires a portlandoregon.gov account. If you don't have one, you can sign up. It's free to sign up for one. If you have an existing one, you can use that existing one for this new PAC. And the new PAC is updated per the 2025 Stormwater Management Manual. This is just a little snapshot of the introduction to the PAC. The PAC can be used to size the following stormwater facilities, also known as green streets when in the public right-of-way. So you can size planters, basins, or slope facilities. And the difference between these facilities are based on the slopes of the sides and the slope of the bottom. So basins and planters have a flat bottom, but planters have vertical walls and basins have sloped sides. Whereas sloped facilities have a sloped bottom and the sides can be either sloped or vertical or a combination of both. You can have one side vertical and one side sloped. And the PAC, there's three different design approaches that the city of Portland has. There's the simplified, presumptive, and performance approach. And the PAC, you can never, if you're using the simplified approach, you can't use the PAC. That's a totally different a design approach that does not use the PAC at all. If you're using the presumptive approach, then you always use the PAC and you're limited to using it within the recommended ranges. If you're using the performance approach, you can choose to use the PAC if you want to, if you're sizing, the planters, basins, or slope facilities. But you're restricted. It can only be done using with a, you have to have an Oregon, you have to be an Oregon licensed professional engineer to use it under the performance approach. And you have a wider latitude of ranges. You're not stuck with the limit, with the recommended ranges. So presumptive and performance you can use with the PAC and simplified, no. There's some new facility options in the new PAC. You can have a recessed underdrain that's shown in the picture here. There's a little where that's where the bottom is the bottom where the blended soil is flat, and then where the underdrain is below that. So it's like you excavate a trench, fill in add the rock, and then put in the permeable or the underdrain. And this kind of shows an example here. The outlet height, it's modifiable, so you can even go above you can have an upturned elbow that goes even higher than the rock. So it has to be at least 6 inches. It can be up to 6 inches below the top of the blended soil, but you can go even above the rock with that upturned elbow. And we also have an added parameter for impervious surface above grade. So like if you have a concrete forebay or some concrete pad, that's used to collect sediments or for maintenance, you can add that into the facility and it'll keep the storage, but it won't allow the water to infiltrate through that concrete pad. The PAC is new, and so there are still some fixes being applied. So for example, one of the big things I was hoping would be fixed before this presentation, but it's still in progress, is the graphs display time steps, but they're labeled as minutes. So you'll see it actually should be 10 times longer. That doesn't change the performance results. All of the pass, fail, and performance results are correct, but some of the labels are like that graph label is incorrect. There's an incorrect description for configurations D and CE. There's some grade boxes that are supposed to provide helpful information, like what your design infiltration rate is, and that's not always accurate. Like the actual values used are correct, but what's being displayed sometimes isn't helpful. So right now, maybe ignore the grade boxes that hopefully will be helpful soon. There's some additional restrictions to parameters we want to add, and the default rock values need some updating. So there's a few fixes. That the actual pass, fail, and performance results are correct, but it's not perfect for sure. So this next part, I'll be going over just an overview of the PAC. There's a projects page, and you can have multiple catchments per project. So when you first go in, create a project, and you can have as many catchments as you want for a project. And then in the catchment page, for each catchment, that has exactly one facility. So those are paired together. And in the catchment page, you enter the details for the catchment. The facility page, you enter the design details for the stormwater facility. And then there's when you can click performance results and it'll give you the performance results for that particular facility. And then lastly, there's a PAC report that you can create to summarize the above information for the selected catchments. The three highlighted ones, the catchment page, facility page, and performance results, are the ones I'm going to kind of go into detail in this presentation. I'll be doing a demo after this presentation. So the catchment page, this is just a quick snapshot of what the catchment page looks like. And I'll be doing a demo again of all of this. So you'll want to, in the catchment page, you'll enter the infiltration test that you used or not applicable, and then enter the measured infiltration rate or not applicable, and then check the box. There's a check box to check if the site constraints prevent full on-site infiltration. And examples of when you might check that would be if it's a contaminated site, steep slopes, or insufficient space for setbacks. With the information, the PAC will determine the design infiltration rate and whether full on-site infiltration is required. So if you choose the open pit, the design infiltration rate will be half the measured measured infiltration rate. If you choose encased, it's also the same as open pit. The design infiltration rate is half the measured infiltration rate. If you choose the double ring infiltrometer, the design equals the measured. That won't show up correctly in that gray box, but the actual math will actually work correctly, and it will be equal to the measured. And we'll be fixing that hopefully soon. And then if you choose not applicable, the design infiltration rate is set to 0. And you'll need to then explain in the stormwater report why you didn't test for infiltration. The next part that you'll enter in the catchment page is you'll select the hierarchy level, and this is the receiving system for the stormwater. So level 1 is if it's going to be that's full on-site infiltration, and that's to groundwater. Level 2 is if it's through the separate storm sewer to a waterway. 2A is if it's going to be to the Willamette River or Columbia River, Columbia Slough, or a tributary or channel of the Columbia Slough. And 2B is any other waterway, if the outfall goes to any other waterway. And then level 3 is to the combined sewer. So if it's level 2, so you have to note which waterway it is, or note where the outfall discharges. And if it's to one of the listed waterways, the Willamette or Columbia River or Columbia Slough or tributary or channel of the Columbia Slough, then you also need to note if there are system capacity issues. And that information determines the performance standards. Additionally, you'll enter the catchment impervious area that's draining to the stormwater facility and check whether the facility is in the public right-of-way. These last two impact the feasibility of flow control. So even if the general performance standards would have some flow control requirements, you might not have those flow control requirements depending on the catchment impervious area and whether the facility is in the public right-of-way. And the PAC will automatically determine the performance standards and whether some flow control requirements are exempt based on what you enter here. And then the next part is the PAC needs information to be able to calculate the stormwater runoff from the site. So you've already entered the catchment impervious area, and that's going to be used to calculate the stormwater runoff. But you'll also now need to enter the post-development time of concentration and the post-development curve number. Typically, you'll enter 98 for the post-development curve number. That's an impervious surface or a typical impervious surface. And time of concentration, it has to be at least 5 minutes because of the math of the Santa Barbara urban hydrograph method that's being used. If shown, you'll also want to enter the pre-development time of concentration and the pre-development curve number. And the pre-development time of concentration has to be at least 5 minutes, and it has to be greater than or equal to the post-development time of concentration. It has to be long, at least either the same or longer than the post-development. And then the curve number, if you're using the presumptive approach, then you'll want to base it on the NRCS soil type, which is shown in that table here. So if you have an NRCS soil type of C, you would use a pre-development curve number of 79. The pre-development time of concentration curve number is only important for flow control. So for the infiltration or water quality treatment only facilities, they're only going to be looking at the post-development. And so ideally, those might not show up. Sometimes we're working on that in the PAC right now to get the irrelevant information to not show up but sometimes it might still show up, but it's only used when you're using flow control. So that's all the information on the catchment page. So the next section is the facility page. And this is where you're enter the stormwater facility details for that particular catchment. And this is just a snapshot of the facility page. So you'll want to enter the first part is information that the PAC will use to determine the facility footprint and the surface storage. So you'll enter the facility type, which is either a planter, basin, or a sloped facility. And for basins, you'll also enter the shape, and that's either rectangular, amoeba, or user defined. And then you'll enter the displayed above ground data, and that will change based on what facility type that you use. So planters, doesn't matter what the shape is, since they have those vertical walls. As the water rises in the planter, it doesn't change the area of the surface. In basins, since they have a sloped sides, as the water rises, the area of the water increases. And so there's additional information that's needed for those. And for slope facilities, because even if they have vertical sides, because they're sloped, the water rising also changes the area of the water area. So for planters, you just need the bottom area width and overflow height. Basins, you'll need the bottom area, overflow height, and then additional parameters for the side slopes, and to determine the area of the basin based on which shape you chose. And then slope facilities can only be rectangular shapes, and you have to add the information shown here. And then the next part of the facility is the information that the PAC needs to route the stormwater through the facility. So you'll want to enter the configuration, and that's just a term that we use to mean the facility components. So configuration A is the simplest facility. It's just the blended soil and surface storage. The water comes in and infiltrates through the soil, and if it starts to more runoff is coming in than can infiltrate, it starts to back up and would eventually overflow. Configuration B is similar to A, except there's subsurface rock storage. So if it starts to back up, it can first back up in the subsurface rock, and then it can back up in the surface and then overflow. The C are a little more complicated because they have an under drain in the rock. So as the water flows into the configuration C, it'll first infiltrate, and then if there's more water than can infiltrate, it starts to back up, and it'll start to back up into the under drain. And depending on which under drain you have, if it's C elevated and your outlet is higher, it can, even when it's in the under drain, it can start to keep building up until it reaches that elevation of the outlet, and then it'll discharge. And then if there's an orifice on this outlet, and it's or the orifice on the outlet, it can keep backing up until it reaches this overflow, which will allow it then to go through. The CL is one where it's a lowered under drain. So as soon as it starts to back up into the under drain, it can exit through the outlet, and there might be depending on what the orifice is on the under drain. And then D is the same as the C lowered, except there's a liner, so there's no infiltration at all. Whatever comes in will eventually starts to back up and then exit through the under drain. And then configuration E, that's one where there's there's an overflow that goes directly to a subsurface storage, and so there's this overflow goes to subsurface storage to promote infiltration, and anything that rises above that could overflow the facility. So depending on your configuration, you'll enter the below grade data and above grade data that is presented in the PAC. And there's for each one of these have different below grade and above grade data based on that configuration. If you chose hierarchy level 1, which is discharge to groundwater or full on-site infiltration, then only configurations A, B, and E are options, because these are the only ones that don't have an under drain with an outlet that leaves the facility. And we want to have, all of the waters needs to be infiltrating, not exiting the facility. So to enter these are all subcomponents of this routing stormwater through the facility. You'll want to add your measurements based on two different datum. So for the overflow heights and the surface storage depth, you'll measure it from the top of the blended soil or the surface bottom. So from this area is where you measure the overflow height, overflow E height, and surface storage depth. For all of the other parameters, you'll measure it from the facility base. So that's like the outlet height would be here, like here's the under drain and the outlet, rock depth are all from the base. And this is another sub component of routing stormwater through the facility. But your typical rock values will be 0.3 porosity, 12-inch depth, a width of 3 feet, or the bottom width, whichever is smaller. An area of 1/4 of the facility length times the rock width is typical. There's a button to give you these values, and that's not giving you right now all the correct values. It does give you the 0.3 and the 12-inch depth, but it's not correctly calculating the area and the width that we want. So I think it's putting it as 1 foot width, and I need to get that changed. But these are the typical values shown here. A maximum is 1/3 of the bottom area, so it doesn't allow you to have more rock than 1/3 of the bottom area to prevent, because we want to have, that encourages plant health. If you design facility, we want to set it up to not set people up for failure and have facilities that have rock across the bottom and the plants all die. So this is to try to keep rock to a minimum so that for plant health purposes. And with the performance approach, so under the presumptive approach, you can only use the standard rock, but under the performance approach, you can use other material for subsurface storage like crates or large pipe, or you can be creative with the performance approach. That does require the person to be a Oregon licensed civil engineer. And as noted above here, all facilities except for configuration A have rock. And then this is also a component of the routing stormwater through the facility. These are different under drain options. Mostly all of these are for configuration C and D, and the recessed under drain is also configuration E. So you can choose whether you want to have your under drain be like a trench that's excavated below the base, at the base of the facility, and the base is actually a little bit lower. So when you calculate the base, it's always from this bottom here, from the very, very lowest part. Or the outlet height, you can adjust the outlet height to be higher or lower. And you can choose whether there's an orifice, yes or no. And if yes, then you need to enter a diameter. And so when you measure these depths, it'll all be from the lowest part of the facility when you have a recessed under drain, or whether you don't have a recessed under drain, it's always that lowest part. And then I think this is the last slide regarding the facility. There's parameters to exclude area from filtration and infiltration. So in the above grade area, you can enter impervious area over the blended soil, and this is new. So this is, if you have like a 4-bay or concrete pad, you can enter in this area to show that it still provides the surface storage, but it doesn't allow for filtration through the blended soil. The water has to actually move over and then filter through the blended soil. You can also enter a percentage of facility base that allows infiltration to the subsurface. And this is saying, like, if you have a partial liner, that covers 50% of the base, you would enter 50% or 50% to show that half of the base doesn't infiltrate. The PAC uses 100% liner for the configuration D, so that's essentially 0% infiltration for configuration D. And it's based on the full facility footprint, including any 4-bay area. So if you had a 4-bay above of, that was 1/4 of the facility or 1/10 of the facility, you would still count that as part of the facility base. So, if 10% of that is infiltrating, then you would put 10%. Or actually, sorry, you would put 90% because that 10% doesn't infiltrate and 90% allows infiltration. And so this is the last section I'll be going into before we go into the demo. And the PAC gives you performance results. Once you've entered the catchment and the facility, it gives you performance results to say whether you passed or failed, and gives you information regarding the rates of flow and volumes of overflow and the size of your facility and information like that. So this is just a snapshot of the performance results. So it gives you the pass-fail, both overall and specific specific metrics. So it gives you the overall pass-fail, whether the facility itself passed, And then it says, the specific performance standards and drawdown, and for configuration E only, also pre-treatment, which I'll go into a little more for all of these. And the relevant performance standards, they vary based on which hierarchy level was chosen, and also if flow control is exempt, if infeasible. So for drawdown, 30 hours after the storm event, there can't be any standing water in surface storage. As I noted before, these graphs are actually in time steps, not in minutes, but this shows you like the surface head and how it drops for different storm events. And it needs to be empty after 30 hours after the storm event to be able to pass drawdown. And then pre-treatment, this is only required for configuration E, and that's because configuration E is an underground injection control registered with the Oregon Department of Environmental Quality, and it always requires pre-treatment. So even if you're doing full on-site infiltration, you have to make sure that none of the water bypasses through that overflow E and goes directly into the rock. All of the water quality storm has to be filtered through the blended soil before entering the rock. And this is for configuration E only. It's not a performance standard, it's just pre-treatment. And then these are the different, and I'll just briefly go into the different performance standards. For full on-site infiltration, you need to infiltrate the runoff from the 10-year storm event. And this is hierarchy level 1 is full on-site infiltration. So your overflow volume during the 10-year event needs to be 0. A really quick trick would be to start with facility footprint. If you want to, for easy math, you can just do 10%. It should be smaller than that, but if you want to start with easy math, you can do 10% of your catchment impervious area and iterate the sizing until the surface capacity, which is that information on the bottom right there, until that gets close to 100%, but just a little bit less, or it could be exactly 100% if nothing's overflowing, but usually it'll be a little bit less than 100%. Yeah, that's the tip for sizing full on-site infiltration. For water quality, this is all hierarchy level 2 facilities have water quality. You have to either infiltrate or treat the runoff from the water quality storm event. And so that means the overflow volume during the water quality event has to be 0. So because these are so much smaller, my tip, instead of starting at 10%, start at 2% of the catchment impervious area and iterate the sizing until the surface capacity used is close to 100%. So you can see this facility could be even smaller because only a little less than 9% of the surface capacity was used. So we could make that facility even smaller. And then for the storm sewer capacity, if the catchment impervious area is greater than or equal to 1,500 square feet, and either it's hierarchy level 2A with pipe capacity issues or hierarchy level 2B, which the PAC will determine for you. You don't have to know this information. But then you have to, for the storm sewer capacity, you need to match the 2, 5, and 10-year outflow peak rates so that they don't exceed the pre-development 2, 5, and 10-year peak runoff rates, respectively. And so a similar tip as the other ones, if you start with a facility footprint of 10% of the size, set the orifice size to the largest that passes, and then adjust the facility footprint or storage to provide storage for larger storms. And then I always, at the end, then check to see if I can just get a little bit smaller orifice. If that still works, then you can make the facility even maybe a little bit smaller. Hydro modification for the pass-fail. These are for catchment impervious areas that are greater than or equal to 10,000 square feet and are hierarchy level 2B and not in the public right-of-way. So this requires that half of the 2-year outflow peak rate not exceed half the pre-development 2-year peak runoff rate. And this is something new. We set the pre-development curve number to 72 for all conditions. This is the forested condition. And this reason is because it's hydro modification is especially sensitive to these really small flows, and getting it to 72 brought it down to a small number that was close to what we were looking for hydromod. A sizing tip: if infiltration is insufficient to reduce the peak, then set the orifice size to the largest that meets the storm and adjust the facility footprint. I typically start at 10% and then work my way down to provide storage for other performance standards. One note is that if your facility is lined, it's going to be very, very difficult, if not impossible, to meet the hydro modification performance standard using the parameters under the presumptive approach. You might need to do the performance approach depending on the size of your facility and the curve numbers and time of concentrations. It's very likely you will need to use the performance approach to meet hydro modification if you have a lined facility. So it's very difficult to do when you have a liner. Just a little bit of infiltration, even like half an inch, is really, makes it totally doable under the presumptive approach. And then sewer capacity, this is, or the combined sewer capacity, this is hierarchy level 3. And this requires that you limit the 25-year, 24-hour post-development peak stormwater runoff rate to no more than the 10-year, 24-hour pre-development peak stormwater runoff rate. And then I have the same sizing tip. I start at 10% and just, just find the orifice size that's the largest that works, and then adjust the facility size down, and then look to see if you can get a little bit smaller orifice and iterate that way. So now I guess I'm ready for the demo, but I want to have some questions if anybody wants to have questions at this time.
Yeah, quick question. So with the facilities, we design it with an overflow to UIC. If the city's stance on registration with DEQ is it's kind of separate. We need to do it, but it's not something the city is going to require for permit up front. Is that right?
Yeah, that's correct. For building permit reviews, the city does not, the city relies on the applicant to get DEQ registration for their UIC, but they do not hold up the permit, waiting for that paperwork.
Okay. It's just, I was thinking about, like, if we design a system and we've maxed out our space, but we've still got a little bit that we want to overflow during the biggest events. DEQ might look at it if that overflow amount is insignificant. They might look at it and say registration not required. Versus if we've got anything over, say, the water quality event, if all of that overflows directly to the UIC, then that would definitely trigger the UIC requirements. I guess where I'm going is just to confirm whether or not it's a UIC. That would be up to DEQ, whether we need to register it or not, depending on their rules. Does that sound about right?
Is your question about whether a specific facility based on the design would be considered a UIC, or whether it's rule authorized versus requiring a specific registration?
First one, yeah, because the DEQ has looked in the past if what actually infiltrates through a UIC, if it's insignificant compared to your total, they won't consider it a UIC that needs to be registered and rule authorized. Okay.
I think we have to admit that we are not super familiar with the DEQ regulations and how they interpret and apply those to specific facilities, particularly unique situations.
Yeah.
So I might have to defer that question.
Yeah, it'd be up to DEQ to, yeah, we don't tell them what their regulations. Yeah, they implement their regulations, I think would be the.
Okay, I think I got the answers I was looking for. We still need to work things out with DEQ, and city will be reviewing stormwater quality and infiltration. So, okay.
Yeah.
Okay. If there are there any other questions, or I'll head to the demo unless there's anything.
You'll probably answer it in the demo. I was curious about the facilities where you can add, some sort of underground storage like UIC. Like, how flexible is that? Is there information input, like If you're gonna use storm check chambers, is that in there, or is
Oh,
it information we would put in? We figure out how big it is, the characteristics, the void space and all that, and then
yeah,
input
it's
that
the
data.
latter. Yeah, we don't have
Okay,
like drop down boxes for types. It's just you give the porosity or the void, how much area that's going to provide.
okay, great, thanks.
So I think I'm going to head over to this is the sign-in page for the pack. If you don't have a portland.oregon.gov account, you can create an new account here, and that's free to do. If you do have an existing one, you can use your existing one and sign in. And I'm going to start by creating a new project. And this is the same as, or very similar to the same one. So I'll just create a test demo address here, Portland. You have some flexibility in what you enter. I'll skip these, but if you have like a permit number, you'd enter that, the designer, the name, company, and then you can summarize demo on the pack, like that. And once you're done with that, you can create the project and it'll let you know you created it. Move this here. And you can edit that if you want to go back and edit it, you can, go back and change anything you want to change. So once you've created a project, and you can also, if you go back to my projects, you can, create more projects if you want to. Once you've created a project, you can then go in and add a catchment to the project. And this is what the catchments page looks like. So the catchment name, you'd like, put a name in there. And for the infiltration testing procedure, you can choose not applicable, open pit, encased, or double ring infiltrometer. Not applicable, it'll set it to 0 for the tested native soil infiltration rate, and have this note down here that stormwater report needs to explain why you chose not applicable. If you choose open pit, you can, put in different values. The correction factor is always showing 2. It is 2 for the open pit and encased, but it's actually 1 for the double ring. And so you can just, these grayed out boxes for now maybe ignore since they're not consistently providing accurate information. It is actually calculating it as 1 in the calculations. So you have these different options for the hierarchy level, and so here's you have, so you have the different infiltration testing procedures, double ring, encased, open pit, or NA. And if you have a high, 8 inches per hour, your only option for hierarchy level is 1. So as long as it's, if it's high enough, your only option, like if you have 4 inches per hour, the design is going to be 2, still only 1. Now, if you select, this says site constraints that prevent full on-site infiltration, suddenly now it's 2 or 3. So you'll have that hierarchy level of 2 or 3, it won't be 1 anymore. If you have a low infiltration rate, like here, let's say it's 1, and the design is half, now you have all 3. You could decide to try to infiltrate since there's no site constraints that prevent it, or you can do 2 or 3. So it's optional. So those are, the hierarchy level is limited to if you have a design infiltration rate of 2 inches per hour or more, and there aren't site constraints, then you have to do hierarchy level 1, and the pack limits you to that. If there are site constraints or the design infiltration rate is less than 2 inches per hour, then you have, if the design infiltration rate is less than 2 inches per hour and there aren't site constraints, then you can choose any of them. But if there are site constraints, then you can't do hierarchy level 1. You're going to do 2 or 3. And so then you enter like the impervious area and choose whether it's in the public right of way or on a parcel. And then you can also check whether, and these different options impact what the applicable performance standards are. And the pack just automatically will show you that. So for this 2-1, water quality, flow control, full on-site infiltration, if you select that it's going to the Willamette River, suddenly, you just have to do the water quality. Unless there are system capacity issues, then you also have to do the 2, 5, 10 year flow control. So things vary, but then if you have like a 1,000 square foot area, that changes now because it's too small to provide that flow control. So the PAC automatically will choose your correct applicable performance standards based on what the information that you enter in this portion here. You know, and then like if you chose 3, it's not going to have water quality, but the flow control will be the combined sewer capacity. So, so after that, then you would enter, you know, the values like 98, 5, 72, and 5, and save your catchment. And now in facility details, you can go down and you can choose what type of facility. So you can choose a flat planter, which is kind of shown here really roughly, a basin, and you can choose whether that basin is rectangular, amoeba, or user-defined. And the difference between these are you could create a rectangle using amoeba or user-defined. It's just a different ways of inputting the information. So user-defined, you just enter the base, the top, the base area, the top area, and the side slopes, and then it calculates the volume. The amoeba, you enter the side slopes, the bottom area, and then this perimeter around the bottom area, and then it calculates, you know, the estimated volume. And with the rectangle, you give the area and the width, and with that, it can calculate the length, and then you also enter the side slopes, and it can calculate the areas. So the shape is just a different ways of calculating the area. If you choose rectangle, then you're stuck with a rectangle. The other ones, you can have any shape, amoeba or user-defined. And then there's also slope facility. You notice with the slope facility, that pops up the slope facility worksheet where you can add the segments information for the slope facility. And then for each of these facilities, you have choices of different configurations. There's the A, B, C, L, CLO, CE, D, and E. The information for D is it's actually a lined facility. So the wording is incorrect. It is D and it is lined, and CE is unlined. Those were switched in the wording. This is one of the tweaks we're working on, but choose D for lined and CE for unlined. Hopefully I will get that fixed soon because that's very confusing. You've got those options there, and you know, then you have the information, and you can validate. Oops, let's see. Oh, I'm going to choose one that let's do a flat planter. It's already got the information there. Validate, check results, and you can see it passes. It infiltrated the 10-year storm event. It's probably a really large facility. Yeah, it's your full area, so that's not a realistic facility. But this just shows you kind of some information as to how the performance results work. So I thought I'd walk through a couple different examples. Unless there's questions right now, I was going to start with hierarchy level 1 and create a few facilities that are real, not 100% sized, and then have the hierarchy level 1's pretty simple, and then do a hierarchy level 2B, which is that requires hydro modification that's more complicated, and then show a few additional pre-made examples. So feel free to, if you have questions as I go along here, to chime in and let me know if you have any questions. So let's see here. I'm going to go to project overview, and I'm going to add a catchment. And this example is going to be road A, and it's going to be open pit. It we're doing infiltration, so I have a really high infiltration rate. There's 12 inches per hour. It's got to be 1 because it's 12 inches per hour. So it's got the design of 6, which is greater than 2, and we don't have site constraints. And I enter the catchment impervious area that's draining to the facility. And I'm going to choose that this is in a public right of way. That's going to limit the depth to 9 inches. Parcels can go deeper, but in the public right of way, we don't want the overflow height or the surface storage depth to be too deep. And this just gives me the information as to what the performance standards are. You have to infiltrate the post-development runoff. I'm going to enter 98.5 here. And if you're curious, you can always, this isn't necessary, but you can validate, check results, and see what the post-development runoff looks like. And it gives you that information and gives you the rates and volumes for all the different storms. So once you've done that, you can save the catchment, and that will take you right to the facility page. And I'm going to start with a flat planter configuration B. So that's infiltration with rock storage. And like I said before, since it's 5,000, I'm going to start with 500 square feet. That's a really easy number to calculate. And it's got the highest overflow height since it's a public facility. It's 9 inches. And we're going to have 24 inches of blended soil and rock. And for now, I'm just going to do, let's see, 104, 12. And the typical rock porosity is 0.3. And we're going to let the entire facility base infiltrate. So that passed, and that's a pretty large facility. It's 10% of the catchment area. And you'll see so the first thing I would look to is to see what's the surface capacity that was used. And I can see that only 9% was used. So I can make it quite a bit smaller. So because only 9% was used, I'm just going to go down and change that quickly. Just like make it half the size. Oops. And when you do that, you also need to reduce the, that error message was saying my rock area is now more than a third, because 100, is more than a third of 250. So I need to bring the rock area down. I'll just make that 80. And I can validate and check results. And that still passed. So then I can see, let's see, I can make it, I'm just doing a little, I won't do many iterations, but I just wanted to show how the iteration stuff worked. So, oops. Need to make this 60. We'll iterate, and basically I'll just bring it down. We can iterate, let's see, validate, check results. And I can iterate all the way down, and I'll just put in the value. It gets down to 197 is the smallest. So I'll show you 196 should fail here. If I do 196, validate, check results. It failed. And you'll see it's 100% of the surface capacity was used. But if I go and look at the overflow, only half a cubic foot overflowed. So that's an indicator that I really only need to increase it by a foot. It's really, really close. So you can look at when the surface capacity is too high, the next thing I look at is how much overflow was there. And it's such a tiny volume that I only need to go bring it up just a tiny little bit. So 197, that should hold. Another comment I got was we want to move these check results to be above the performance results, not at the bottom, so you don't have to scroll as much. That's something I'll try to do. And so you can see now at 197 that passed. And now so this is configuration B. And the infiltration rate is the design infiltration rate is 6 inches per hour. And so because we'd entered 12 inches per hour, but it was open pit, so it was half. So the design infiltration rate is 6 inches per hour. So I use this example because in this case, rock really isn't important. If I have a rock area of 1 square foot, I can hit validate and check results, and you can see it still passes. So really, I don't need a configuration B facility for this. I can use just a full infiltration, which is the best, great for plants. You don't have any rock at all. 197, I'll scroll down here and validate. Let's see. Oh, I need to change the blended soil depth for configuration A can only be up to 12. And so those little things, it'll tell you if you're outside of a range. But yeah, but even without any rock, this passes. So configuration A works. Now I'm going to look at configuration E. That's the one that can be an underground injection control. And if I have to change the overflow E height, that has to, if I were to try to enter this, it'll give me an error because the overflow E height, and you'll see it won't let me validate, and that's because the overflow E height must be lower than the overflow height. So it has to be, that needs to be the lower one where water first goes into the rock, and then the overflow is where it exits the facility. So I'm gonna put a 6 inches there and validate, oops, rock storage. Oh, and I went straight from an A facility. Now we actually do need rock storages in this example. In the B, we'd had 60 square feet of rock, which if you remember, that wasn't relevant. That wasn't important to the sizing for B because the infiltration rate was fast enough. It wasn't backing up into the rock. It was just going straight through. But in this case, because the E brings it to, lets it bypass the blended soil and go directly in, the rock will matter a little bit. And so we have 60 inches, 12-inch depth, and I need a 24-inch depth of blended soil and rock. And when I do that, you can see it again, it passes for E. And I can actually make the facility a little bit smaller. It's not much smaller because it's 6 inches per hour, but if you start to go into larger infiltration rates and configuration, E does start to matter. This is only, it'll let you go down to 180. So I can make the surface storage just a little bit smaller from 197 to 180. If I do 180, I can go validate, check results, and it still passes. If I were to go 179, it fails. So those are the different options for the simple, just full on-site infiltration. I'm going to go back to A just to give a couple examples regarding the impervious area over the blended soil and the percentage of facility base that allows infiltration. So, so on the bottom area for A, this is going to fail at 190. We need it to be 197 was the value that worked. So 197, the blended soil depth is 12, because that's the maximum for configuration A. And I'm going to change this to, instead of 100%, we're going to say it's 75%. So I'll first show you at 100%, this should pass. I'll hit results. And this passes. But if I choose, now if I have only 75% of the area that infiltrates, so there's a 25% liner. If I go down, validate, check results, it doesn't pass anymore because there's that liners preventing some of that infiltration. So I need to get it all the way up to, you know, I need to bring it up, I think, to C2, 226, I think we'll let it pass. But you just kind of bring it up a little bit until it starts to work. And so you can see that's where it just passes 99.5%, 57% of the surface capacity was used. If we make it any bigger, it's going to start to overflow, and you can't have any overflow from the 10-year storm for full on-site infiltration. So this is sized appropriately with a 75% liner. Now, let's say you let's say this is on a roadway where there's a lot of sediment and you want to have a concrete pad or a forebay, and you put a 50 square foot forebay at the front of it. That's actually not going to have any impact in this case because of the fact of the facility base having that liner, and this impervious area over the soil is less than that 25%. So you'll see it still passes. But if I make it a little bit bigger, like let's say I make it a little bit more than, like if I make it 60 square foot pad. So the previous pad was 50 square feet, and now it's 60 square feet. I make it just a little bit bigger. That's going to cause it now to fail. And so I need to just make it, I need to make the facility. And so if I look at the, if I look at why it's failing, submerged capacity was 100%, which meant there's a little bit of overflow. The overflow volume is 9. So it's not a lot, just a little bit, 9 cubic feet, 0.0082 CFS. So just a little bit bigger. The amount, so like the last one was like less than a foot, you know, and so I only needed to increase it by a foot. But in this case, the amount that I would need to increase it to is to 231. And this is for a facility that has blended impervious area over the blended soil, and there's a 25% liner, meaning 75% of the facility base allows infiltration. In this case, if I validate and check results, you can see then it passes, and it got to 99.88. So you'll know you're really, like, when you're in the 99 point something range, you're very close or at your optimum sizing. So that's the portion I wanted to give regarding infiltration, showing. And now my next example will be for one of the more complicated facilities, which is ones that need an orifice for hydromodification and for storm sewer. So I'll save this facility, and then I'm going to create a new one. I'll add a catchment, and I'll just call this like catchment. See, let's call it, I guess, B. And I think I might already have a catchment B. I'll call this G. And then in this case, I'm going to use an encased and with 1 inch per hour, and the design infiltration rate when it's encased or open pit is half the measured infiltration rate. So that means that the design infiltration rate is 0.5. It doesn't have any site constraints to prevent full on-site infiltration. And we're going to use hierarchy level 2 with an impervious area of 10,000. Notice for 10,000, and it's in it's a parcel. So notice in this case, this requires full flow control for hydromodification as well as the storm sewer. So you've got a lot of flow control requirements here. If it was to a discharge to the Willamette River, you wouldn't have that, but in this case, it's a discharge to smaller waterway. And if it was also to the public right of way, notice, like, if you look at this hydromodification part under flow control, if it was to a public right of way, you wouldn't require that. It's only if it's 10,000 square feet or more on a parcel and it's not to one of these listed waterways. This is the most complicated situation, but you can still do it if it's at a low infiltration rate of 0.5. So I'm going to enter in, I think I need to put it in, I'm going to put in I have a 15,000 square foot impervious area on a parcel, and then I'll enter in 98, and the 5 is the minimum, but you're not stuck to 5 in this example. I'm going to put in 8 minutes, and this has to be so that when I go to the pre-development needs to be the same or larger. I'm going to do a 25-minute pre-development time of concentration and a CN of 72. So I'm going to validate and save the catchment. And it takes you right to the facility, and it shows the information in the catchment details. You can see the project name, the catchment details. If I wanted to go back to the catchment, I could go back by clicking here. And other facility details, you can choose any type of facility. The simplest one to start with is planter, and then adjust the size to a different one. So I'm going to start with the planter, and I'm going to choose the CE. This is says lined. It's actually, hopefully I'm correcting that soon. It's actually the CE, which is the elevated without a liner, an elevated outlet. And I'll start off with, like I said, I start off with just for a simple start, bottom area, 10%. The bottom is, so it was 15,000 square feet impervious area. So I'm choosing 1,500 for the bottom area. And the overflow height, since it's private, it can be 18 or it could be higher. It's not limited to that 9. I'll choose the standard depth of blended soil plus rock of 24. And let's see here. And let's say I have 50 square foot pad at the top. Then the rock area, that it can't be any more than 1/3 of the area, but you can make it a lot. So you can make it smaller. So I'm going to just do 200 square feet of rock, 3-foot wide rock, 12-inch storage, the standard rock. So it's the 0.3 porosity. Overflow height, I'll start off at 12. So it's at the top of the rock, and 100%, we'll say that it can fully infiltrate. And this does need an orifice for the flow control. So I'll start off with 1. I typically start off with kind of something that I think is going to be large, and then work my way down. So you can see that, let's see, this fails because it's the facility, that orifice is too large. It's allowing, the hydromodification storm, it's 0.15 to 0.0058. The 2-year storm is 0.02. the stormwater facility outflow as allowing way more, it needs to be equal to or less than pre-development. So you can see that that orifice is too large, and that's why it's failing. So I'm gonna bring it down. It's quite a bit too large, so I'm gonna bring it down a couple and see if, does that work? And the answer will be no, but I wanted to show how this works. So you can see it's getting closer, like this is 0.016 and 0.00.011. So it's getting closer, but it's still too large. And I like to start with a large facility to kind of fine tune what the orifice size is, because I don't want the too small facility to be the reason why it's failing. I want it to be the orifice, so that I can kind of get the orifice size correct first. So then I'll bring it down just a little bit more and see if, 5/8. Well, and I'll 5/8 ends up failing too, so I'll just go down straight to the, half inch works. So I can do validate, check results. And here we have a 10% sized facility, sizing ratios. We don't really want that facility. It's kind of big, but it passes. But it's really large. So we want to see if we can make it smaller. So, so this is just the iteration process. So first you have a large facility, kind of find an orifice that works, and then bring your facility down to the smallest that still works. So the smallest, if I do 1,100 square feet, and I can see there's room for passing, because you can see there's nothing going through the overflow, and the surface capacity, so there's nothing going through the overflow at all. And the water quality storm, the surface capacity used is 0, but that's not as important as the fact that there's no overflow here. So I can make it a little smaller, and I go validate, check results, and you can see that's a little bit too small. 1,100 square feet is a little is too small for this facility. So I'm going to check in, like, if I do, let's see, like 1,200 square feet. This passes, and you can see it doesn't have to meet all of the performance standards that are listed, because in the case of hydromodification, you can do water quality infiltration or hydromodification. You don't have to do both. So in this case, since the water quality storm is infiltrated, it doesn't have to meet the flow control for hydromodification. So this facility passes, and so the overall status is pass, and it tells you which performance standards were met, that passed or didn't met, which are the relevant performance standards, but you don't always have to meet all of them. In this case, hydromodification or water quality infiltration is allowed to meet the overall standard. But once I get to a passing size, there's a little bit of iteration required for sizing a facility with an orifice. So sometimes you can bring it down just a little bit more, and that might make it, you can bring the orifice diameter down a little bit smaller, and it'll allow you to infiltrate, or allows you to get your facilities a little bit smaller. So I'm going to bring it down to 3/8 and see if that still works. So if I chose a 3/8 inch orifice and I validate and check results, and you can see that still passes. And actually that allowed the hydromodification, that's a small enough orifice that now the hydromodification also passed. And you can see the hydromodification is 0.0037 and 0.0058. So it can be a little bit bigger. It actually really brought it down a lot. So we can bring the facility size, and it actually can go down all the way down to 140 square feet. Validate, check results. And this time you didn't meet the water quality infiltration, but you did meet the hydromodification, and only one of these has to be met. And so the overall status is still pass. So you can see, and the facility size ended up being 6.93% of the area. So a reasonable sized facility with only an infiltration rate of 0.5 inches per hour. Now, if you change it to D, that's going to be like, when you change it to D, you'll see, validate, Oh wait, I need to have, there's more restrictions on D. But with D, there's a full liner. And so I will need my outlet height. I'll make it 4 inches. And impervious area. Okay. When there's, okay, there it goes. When it's fully lined, you can see it fails with the same facility where the liner fails, and you'll see that it's a lot higher. It's, you know, it's double in these cases, how much the outflow is from the stormwater facility compared to what it needs to be. So, and there's, you know, quite a bit of overflow volume that's causing that. So, like, let's say we bring it back up to that, you know, 1,500 square foot area. That's the 10% sized facility. And you can see it still fails. And the reason why, even though it's this huge facility, is now the drawdown didn't work. And this is what causes the complication when it's a lined facility. When it's a lined facility that requires hydromodification or water quality infiltration. It's really tricky to get the drawdown to work and meet all the performance standards. And that's because you'll see, as you look at the surface storage graph, it didn't, like, it's not drawing down within the 30 hours after the rainfall event. The orifice is small enough that it's reducing the rate at which it flows out. And the facility is big enough to contain, you know, the 10-year and the 5-year and all the different storms, but it's not draining down because of that small orifice. It's not draining down. It's taking more than 30 hours to drain down that surface storage. So ideally what you need to do, and I'll show that as an example because it takes some time to get to it, but you can change this rock porosity. And that was the question that was asked earlier about how to change the sizing. So you can help by, like, you know, having your rock area, like this is, you're showing 200 square feet. It doesn't have to actually be rock. If you're using the standard rock, it should be 0.3, so it'll give you that info. But if you're not using the standard rock, you're using the performance approach, you can have a larger rock porosity, and that will help. That's not going to be enough in this case. I'll show you it's still going to fail because there's a lot of iteration to get it to fine tune it to a successful facility. Yeah, see, this still fails, but that's adjusting the height and rock porosity and working on the parameters can get you to a working facility, which I'll open up as I just created an example instead of working on the iterations for a performance approach type facility. So if I go to my projects and presentation, check to see what the name of it is. This one here. So this particular facility, and this is the one that's going to require a performance approach. In this case, I chose not applicable for infiltration testing. So the stormwater report should explain why the test infiltration rate is the PAC assumes 0 since it's not applicable. And it's a 10,000 square foot area on a parcel. You've got crib number 79, pre-development 10 minutes for the pre-development condition for the time of concentration, and then 98 and 5 for the post-development. I'll save the catchment, and you'll see here in this particular example, it's 8.5% of the area. It's got 10 inches overflow height, so it's just a little bit more than public facility. It's deeper blended soil and rock, and it doesn't have a huge rock area, but the porosity is really high. It has a high porosity. So it's basically like crates or something, you know, or a big or like a pipe or some sort of storage area. And if you can do something like that, you can validate, check results, and you will pass. You can pass and provide the drawdown in time because your storage is in the subsurface, not in the surface, because drawdown doesn't count what's below the facility. So you can be drawing down for a long time in the subsurface. It's just, you can't draw down if you take more than 30 hours to draw down in the surface storage, then that won't pass for the drawdown metric. But this is an example of it working. And you can see it still takes a long time for it to draw down, but because a lot of the storage is in subsurface now instead of surface, that helps it so that it can draw down below the facility instead of at the top.
For these situations, is the under drain rock area limited to a third of the surface?
We still have it limited to a third, yes.
I'm just thinking, like in this example, you were having, I think, 4 foot of soil depth,
Yeah, it's deep, yeah.
which is great for the plants. And it feels like if you were doing something like that, might be able to, if you could override the rock storage underneath that, get a bigger footprint. It might help
Oh, yeah,
get more volume.
I should add too, though, and that is, that was something we did look at, as a possibility of adding, extra rock storage. Because of plant health, we kept it at 1/3, but there is validity to adding that. Right now, the pack doesn't have that option. But I do want to, make it clear that the total depth of blended soil plus rock, that includes that rock depth. So there's only in this case, there's 18 inches of blended soil above the rock. But,
Sorry.
this 48 here is the depth of blended soil plus the rock. So it's that total depth, including that 30 inches of rock. So it's got 30 inches of rock and then 18 inches of blended soil above the rock. And then the area next to the rock is 48 inches of just the blended soil. So it's that the blended soil is 48 inches where there isn't any rock, but where there is rock, the blended soil is only 18 inches.
Okay.
So that's an example there. And then I have several just examples to show, like if you wanted to create a slope facility, this, and I'm in the facility page, but if you want to go, I'm in the catchment page. So for a slope facility, this is hierarchy level 3. So that's to the combined sewer. And, I can save catchment. If I wanted to go back to the catchment, I could go hit view tape details, and I'll be back in the catchment page. And here you can add segments. So, I can say like, this is a 30-foot segment length with a longitudinal slope of like 0.03, bottom width of 3. I'll make it planter walls, so they're both 0. Like it's a 0 horizontal to 1 vertical. Down gradient depth, we could do like 9, and landscape width of 5 or something. And so this part is the information. The slope facility gives you each segment of the slope facility, so you can continually create more segments. And this starts from the upstream segment and works your way down. And so this is the downstream segment. And then it also gives you information to enter the depth of blended soil plus the rock and the impervious area over the blended soil, and any like the below ground data as well. And including like the orifice and the outlet height. And you can validate longitudinal slope must not exceed 20%. Let's see.
The Mr. 0.
You
have 30%.
Oh, yes. Okay. Thank you.
Yes.
So it's 0.03. But it will tell you if you go too high. So there's some of those little checks to help your facility. And then this checks for the flow control for the combined sewer capacity. The 25-year post can't exceed the 10-year pre. And so you can see in that case, the 25-year post is less than the 2-year pre. So that is successful. So this is an example of a slope facility configuration D. If I wanted to, let's say I wanted to you can delete a segment that you added. I'll delete that segment and then check and validate and see if it still worked. Like, did I need that extra segment or not? And in this case, no, it still works. And this case, you can see it's very close, 0.0237 to 0.0238. So I really can't lose much. I can't delete another segment. It's super close. Like I need all those segments, for, to pass. And then I'm gonna quickly go in and show where you go to do the PAC report. So with the PAC report, if I were to just click on it, it's going to give me a failure because I have to select a catchment. So I'll, select a couple catchments, and let's do B and this one. And you can just choose one or you can choose several. I just chose 2 there, and you can generate the PAC report. And that will give you the information that you entered in the project details at the top. And it gives you a project summary that shows, how big your facility is, your configuration, hierarchy level, the catchment name. And then it starts with the first catchment that you have, and it provides just a summary of all the information that you entered and a summary of the design, the calculated values, and shows you, the different graphs. And then it shows you for that first facility, of that first catchment, then it also shows you the facility that's paired with that first catchment. And this is the information that you had entered for the general information, and then the above and below grade storage data. And then it tells you the metrics of what you passed, which performance results were passed. In this case, and water quality infiltration only one of either hydromodification or water quality infiltration need to be met. So saying no there is perfectly fine. It's just valid. It's just information to see whether you infiltrated the water quality storm or not. And it provides us the graph information, and then it gives you the information for the next facility. And so you can see, the catchment information for the next facility, or the next catchment, and then the next facility, and the pass failure. And at the very top, it gives you the overall status. So you can see that's the very important thing, like did it pass or not overall? And these both passed. So didn't meet water quality infiltration in that case, but it doesn't have to. It could, because it provided hydromodification flow control. And then you can print your report. You can select an option to save as PDF or, see. And then, then you can choose to either print it, but you can choose it, print it as an Adobe PDF or to your printer. So that's kind of the general overview. I don't know if I wanted to leave a room for questions, so I don't know what time it is. I guess it's just a little after 1. I guess if there aren't any questions, I'm going to bring it back to the general slide so you can see my contact information. Because if you have questions, you can reach out to me, or if you notice additional errors that were beyond the ones that I pointed out, also let me know. I'd love to get those corrections made.
I do have a question. I apologize, I haven't been through the updated manual thoroughly yet, but there's now asking about proximity to the river and downstream capacity for detention. Are there maps in the new manual saying, these properties adjacent to the river would be considered draining directly to the river, or these ones go into a dedicated storm sewer, but it's got a downstream restriction? Is that information in the updated manual, or?
We don't have those maps. I guess you like, so we do have information like for the storm sewer system. If it's the public storm sewers, if it's the public storm sewer system, and it's less than, if it's 12 inches or less, or if it's less than
more,
12 inches or more,
then you don't need.
yeah, if it's less than 12 inches, then it's considered to have storm sewer capacity issues. If it's private, then it depends on the owner. If the owner says that there's issues and they want flow control, then you'd have to do flow control. But for public pipes, it's if it's less than 12 inches.
And a lot of that sort of non-city flow control requirements, often that applies in sites that are in the flood control and water quality district. So in the drainage districts, they're the ones who, that's the most common situation when the city isn't making that determination about when flow control is required. But really how that applies depends on like where the water ends up ultimately. So it's not whether the site directly discharges to the Willamette, the Columbia, or the Columbia Slough. It's if the pipe that it discharges to goes there eventually without running through another water body first. So, and Portland Maps is the best place to figure that out. And if there's confusion about your site, the best thing to do is probably set up a 15-minute appointment with PP&D.
Okay. Thanks.
Yeah.
Okay, I guess I'm gonna move it to the screen. So slideshow. Yeah, so if you have additional corrections needed on the pack, or if you have questions, if you see additional corrections, or if you have any questions, feel welcome to contact me at amy.simpson@portlandoregon.gov. And
you can also email our sort of generic inboxes on our main SWM webpage. So you can also reach out to that email address if it's easier for you to find.
Okay, well, thanks everybody.
Yeah, thanks so much.
I guess I'll unclick the meeting recorded.
Thank you.